misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat petang dan salam Malaysia Madani. Sebelum kita mulakan pada kelas pada petang ini, mari sama-sama kita buka majlis dengan Ummul Kitab Al-Fatihah. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin amin ya rabbal alamin. Bismillahirrahmanirrahim. Allahumma shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Sekali lagi saya ucapkan selamat datang dan terima kasih kerana mengikuti kelas fizik tuition online percuma dibawakan oleh Akademi Youtuber Malaysia dan dikuasakan oleh Kelab Guru Malaysia dan e-Didik Malaysia. Bermula percuma, segalanya selamanya percuma. Alhamdulillah, syukur kita kehadrat ilahi kerana dengan izinnya dipertemukan kita sekali lagi pada petang ini untuk kita sama-sama mempelajari tajuk yang seterusnya dalam kelas fizik tingkatan 4. Tajuk kita pada petang ini iaitu 5.4 pembiasan gelombang, refraction of wave. So kelas ini untuk pelajar DLP, namun murid-murid yang bukan DLP juga boleh mengikuti kelas ini. Sebelum itu cikgu nak bagi tahu, cikgu ada kongsikan link bahan pada petang ini. Anda boleh lihat pada pin message seperti yang tertera pada skrin sekarang. Sebelum tu kita ada Rashid Reza di sana. Waalaikumsalam. Alhamdulillah cikgu sihat. So Rashid ni cikgu ke student ya? Boleh tak perkenalkan diri sekejap? Okey, tulis dalam chat sama ada cikgu ataupun murid, pelajar. Kalau anda pelajar, anda belajar di sekolah mana. Begitu juga dengan yang lain. Jadi insya-Allah petang ini cikgu bersendirian sahaja, tapi tidak mengapa. Saya percaya ada ramai di sana yang sedang bersama-sama dengan cikgu. Jadi sebelum kita bermula, ayo kita kongsikan lagi link kelas pada petang ini. Mudah-mudahan ramai lagi yang dapat manfaat apa yang akan kita kongsikan pada hari ini. Study di Perak. Okey, terima kasih join kelas cikgu pada petang ini. So Rashid boleh dapatkan, boleh muat turun nota yang cikgu kongsikan dan ada ruang kosong untuk bahagian latihan. Boleh cuba latihannya, nanti kita jawab bersama-sama. Okey, jadi tanpa membuang masa lagi, mari kita teruskan kelas pada petang ini iaitu tajuk kita 5.4 pembiasan gelombang, refraction of wave. Alright students, so as I mentioned earlier, this is free online tuition powered by Akademi Youtuber Malaysia with the sponsor pun Kelab Guru Malaysia dan e-Didik Malaysia. Kita cooperation combo. So bermula percuma, selamanya percuma. That is our tagline. Okay, so without further ado, so this is the slide for this chapter. So can you see my screen, Rashid? Boleh nampak tak screen cikgu? Okay, and can you hear me as well? Boleh, kalau boleh dengar cikgu dengan jelas, boleh respon pada live chat di sana. Sekali lagi cikgu kongsikan link untuk PDF copy kelas kita pada petang ini. Alright. Okay student, if you are good to go, so let us begin our topic today, refraction of wave. So this is Physics Form 4, Chapter 4. Before that, this is our schedule for this week. Ini jadual kelas kita pada minggu ini. Telah disampaikan pada Jumaat lepas oleh Cikgu Rosemawati. Kelas Fizik tingkatan 5. Tajuk dia Fizik Nuklear 6.1 reputan radioaktif. So siapa yang terlepas kelas ini, jangan risau. Anda boleh tonton semula di channel Cikgu Rosemawati. Boleh tonton juga dari channel Teachers Linda Nordin. Dan bolehlah ikuti kelas ini bila-bila masa anda lapang. Itu kelebihan kita adakan kelas secara langsung di YouTube. If you miss the class or part of it, so you can rewatch later when you have a free time. Okay, so untuk petang ini cikgu akan sambung untuk kelas tingkatan 4, 5.4 Refraction of Wave. Okay, so this is our Fizik panel in Akademi Youtuber. Inilah barisan guru yang banyak membantu cikgu untuk menerbitkan video-video PDPC ataupun sebagai penyampai dalam kelas-kelas tuition online percuma di Akademi Youtuber. So harapnya video-video yang kami terbitkan ini memberi manfaat kepada bukan saja pelajar tetapi juga guru-guru fizik di seluruh Malaysia. Dan ini adalah aplikasi yang anda boleh muat turun di Android anda. Boleh dapatkan di Google Play Store. Muat turun secara percuma. Nama apps dia Akademi Youtuber Apps. Type saja di Google Play Store. Apa yang ada dalam ni, kita ada puluhan ribu video PDPC untuk pelbagai subjek melibatkan peringkat daripada prasekolah hinggalah ke pra-universiti. Jadi semoga video ini membantu anda dalam pembelajaran seharian anda. Okey. Jadi tanpa membuang masa, ayuh kita mulakan kelas pada petang ini. Okay, let us begin today's lesson with the first learning standard 5.4.1 to describe refraction of wave from these following aspects. So what is angle of incidence, angle of refraction, wavelength, frequency, speed? You have known these terms in the first lesson 5.1 fundamentals of wave with Mr. Pekok Hua last time. Okay, anda sudah tahu apa semua maksud istilah ini. So we are going to see what's happened to all these aspects when wave undergo a phenomenon which is called a refraction. Alright? Okay. So students, let us take a look at this situation. Okay, can you observe the motion of the car? What happened to the car as it moved from the road into the mud? Cuba perhatikan pergerakan kereta. Apa berlaku apabila kawasan yang happen to it? Macam mana nak tulis? Perhatikan, you can see with your eyes. Okay, so any response you can type in the live chat. Alright. Okay, Riza, agak-agak apa jawapan dia, Rashid? What happened to the car? What happened to the motion of the car? Any changes? So you can see clearly the direction is changes. Yes, so the direction of the motion of the car changes as it moves from one medium, which is the road, to another medium, which is the mud. So arah pergerakan kereta berubah apabila ia bergerak dari satu medium ke medium yang lain. Medium yang pertama jalan raya, medium yang so this is how we are going to relate with today's topic. Okay, kita tengok yang kedua. Okay, this is another example of phenomenon. So what you can see in the first diagram there, the light wave. So changing in direction as it move through different medium. So did the water wave here. It changed direction when move from different depth of water region. And the third GIF also show the same. Okay, the movement of light wave is changes as it propagate from air into glass and then went back to air. So this is to give us the idea that the direction of propagation of wave changes as it propagate from one medium to another So bila anda perhatikan semua animasi ini, kita dapat idea arah perambatan gelombang berubah apabila dia merambat dari satu medium ke medium yang lain. Okay. Then students, we can come to the definition of refraction. So what is refraction of wave? Apa itu perambatan gelombang? Apa itu pembiasan gelombang? Yes, okay. So from the few observation and example we see previously, we can say that refraction of wave refer to the change in direction of propagation of wave caused by the change in velocity of the wave when they propagate from one medium to another. So pembiasan gelombang adalah perubahan arah perambatan gelombang yang disebabkan oleh apa? Disebabkan oleh perubahan halaju gelombang apabila ia merambat dari satu medium ke medium yang lain. Okay, so this is the definition for refraction of wave. The highlighted word is the key word for the definition. Change in direction due to change in velocity when wave propagate from one medium to another. Alright. Okay, then this is a few example of changes of propagation involving different medium. Okay, the first diagram you can see speed of light wave is influenced by optical density of medium. So you will see the pencil appear to be bent in water. So this is because as light travel from the water into the air, so it experience changes in speed or change in velocity. So this will cause the changing in direction as it enters the eyes of the observer. So the pencil will appear to be bent inside the water. And the second example, the speed of water wave is influenced by the depth of water. So water will travel at different speed in low region, in shallow region and deep region. Gelombang air mempunyai halaju yang berbeza di kawasan dalam dan di kawasan yang cetek. So perubahan halaju ini menyebabkan perubahan arah perambatan gelombang. Okay, then the third example, the speed of sound wave. Okay, this shows refraction of sound wave. So the speed of sound wave influenced by the density of air. So as sound wave travel in the air of different density, so the speed changes. So the direction is changes. So it will be refracted either towards the ground or away from the ground. We will talk about that later. Okay, so again, these three pictures shows to you how refraction of light wave, refraction of water wave, and refraction of sound wave occur. Okay. Okay, next students. Okay, this is one example of experiment in your textbook, or this is one of the compulsory experiment for Form 4 to study the refraction of water wave for plane wave. Okay, refraction of wave for plane wave. So this is the apparatus required. Ripple tank. Okay, ripple tank is the apparatus we can see to observe or to study the properties of wave. Alright, so this is all the apparatus required. So do the material. You can read them later. Okay. And this is all the procedure involved from number 1 up to number 7. So first, we set up all the apparatus required. So when we switch on the ripple generator, so you can see a plane wave at low frequency will be produced. Okay, and you can read number 3, number 4, number 5, number 6, and so on. All right. So this is how what we need to find in this experiment. So later, you will need to determine the following values. Okay, find the angle of incidence, angle of refraction, incident wavelength, and refracted wavelength. Okay, and the experiment is repeated from shallow region to deep region. So to study refraction, we will create a situation inside the ripple tank of deep and shallow region. So we are using the perspect sheet. We put it inside the water to create a shallow region on top of it. Okay, so kepingan perspek ini kita letakkan di dalam tangki riak yang telah diisi dengan air untuk mewujudkan kawasan yang berkedalaman cetek. So kita akan lihat pergerakan air daripada kawasan dalam ke kawasan yang cetek dan sebaliknya daripada kawasan cetek kepada kawasan dalam. So we will observe the pattern of the water wave produced from both situation. Alright, so I hope you are clear or the picturize of the experiment. So this is the observation we are going to. Ini pemerhatian yang akan kita lihat. Okay, so students, when the water wave is propagate from deep region to shallow region, you can see this is the changes. Okay, ini perubahan yang berlaku. Okay, the first one you can see the wavelength. Nampak tak? Anda boleh dengar cikgu sekarang ya. Baru saya perasan mic saya tadi adalah dalam keadaan mute. Okay. Sebab tak ada yang menunggu di sana, so I think it's audible now. Anda boleh dengar cikgu? Okay, so kita terangkanlah semula. Okay, so ini adalah pemerhatian untuk eksperimen yang pertama. Kita menggunakan tangki riak untuk memerhatikan pembiasan gelombang air. So this is the observation from the experiment conducted to study refraction of water wave using a ripple tank. Okay, so again the perspective sheet is used to create a shallow region in the ripple tank. Kita menggunakan kepingan perspek untuk mewujudkan kawasan cetek pada di dalam tangki riak. Okay, so students, again, so this is the GIF shows what happened when the water wave propagate from the deep region to shallow region. Okay, so you can see number one, you can check on the wavelength. Okay, did you notice the wavelength in the deep region is longer, right? And as it entered the shallow region, what happened to the wavelength? The wavelength becomes shorter. Okay, the wavelength is shorter, become closer to one and another. Okay, that is the first observation we can make. And second, we can see the direction of propagation changes. Okay, once it propagate from deep region to shallow region. Okay, so I have used one tips for my students in order to understand where will the wave propagate to from when they propagate from deep to shallow region. Either they will propagate towards normal or away from normal. So I use duit saya tiada. Okay, duit saya tiada. Duit saya tiada mean from deep to shallow. So what happened? It will propagate towards normal. Okay, from deep to shallow, so the wave will propagate towards normal, as you can see in this drawing down here. Okay, I'll show you again. So from deep region, this is the incident wave. So this is the normal we draw to the boundary of the deep region and shallow region. So it will propagate towards the normal once it enter the shallow. So this is the formula, duit saya tiada. From deep to shallow region, the wave propagate towards normal. Alright. And then for the second situation, okay, now we do the other way round. Okay, we let the water wave to propagate from shallow region to deep region as shown in the video up there. Okay, can you see the propagation of the, it's a very short video though. Okay, so in this situation, I also use one formula here, SDA. Saya dapat ampau. Tadi saya tak ada duit, duit saya tiada, sekarang saya dapat ampau. Okay, S refer to shallow, D refer to deep, A mean away from normal. So we understand when the water wave propagate from shallow to deep region, it will be refracted away from normal, as you can see up here. Again, here is the incident wave in the shallow region, and this is the normal line at the boundary between both regions. So this is the refracted wave. It refracted away from normal. So you can see that angle of refraction is greater than angle of incidence since it is refracted away from normal, and we can draw the new refracted wave there. Okay, where the wavelength is longer. So we draw the line perpendicular to the refracted wave, and we do the line further than one to another to show that the wavelength is longer in deep region. Okay, can you follow me up to this point? Anda boleh ikut cikgu tak hingga setakat ini? Okay. Then, students, so this is the changes, okay, of the property of wave when the wave undergo refraction. So the first one, we can study the angle of incidence and angle of refraction. Okay, this is the situation where the wave propagate from deep region to shallow region. The next column, when the wave propagate from shallow to deep region. Okay, so first, what happened to the angle of incidence and angle of refraction? So I greater than R when the wave travel from deep to shallow region. Okay, as it refracted towards normal, so that's why R will be less than I. Okay. Meanwhile, when it travel from shallow to deep region, what happened? R will be greater than I. Okay, since it is refracted away from normal. So angle of refraction will be greater than angle of incidence then. Then what happened to the wavelength? As I mentioned earlier, when the wave propagate from deep to shallow region, so what happened to the wavelength? The wavelength decreases. It is longer at the deep region and shorter at the shallow region. So we say it is decreasing. Alright. And when the wave travel from shallow to deep region, mean the wavelength will be increases. Okay, it is shorter at the shallow region and longer at the deep region. So it increase. Alright. While the frequency remain, okay, in both situation. Why? Because it is produced from the same sources of wave, same deeper to produce the wave. Alright. While the wave speed, okay, so the wave speed is higher at the deep region and lower at the shallow region. So here the wave speed decreases from deep to shallow, wave speed decreases, similar to wavelength. Okay. Meanwhile, when the wave travel from shallow region to deep region, what happened? The wave speed increases. All right. And then the direction of propagation of wave. So we use the formula just now from deep to shallow. So DST, duit saya tiada. So tiada mean towards normal. It will be refracted towards normal. Meanwhile, from shallow to deep region, SDA, shallow, deep, away. Saya dapat angpau. So it is refracted away from the normal. Alright, I think if you don't have any other formula, you can use my formula of saya dapat angpau dan duit saya tiada to understand the direction of propagation of wave either from deep to shallow or shallow to deep region. Alright, okay, so that goes for the first learning standard. Okay, to study the propagation of water wave using apparatus called a ripple tank. Alright. Okay, now let us go to the second learning standard, how to draw, okay, the diagram to show refraction of wave for two different depths. Again, we are going to deal with a refraction of water wave. All right, so I hope you are ready with your pencil, your ruler, and so on. So we practice to sketch this together. Okay, so actually you can find this in your textbook. Boleh tengok dalam textbook. So there are 4 steps involved. Okay, the first one, okay, this is the paper to show our 2 different region. Okay, here above is a deep region, and then down here the blue color is the shallow region. Okay, so this is our incident wave. Okay, this is the incident wave. So first what you need to do, you have to draw an arrow line AB perpendicular to the incident waveform. This is to represent the direction of propagation. So this is the first line we draw. So this is the incident wave. Okay, this is the direction of propagation of our incident wave number 1. And then second, we draw the normal line. Okay, this is the normal line. Number 2 there. Normal line is a line 90 degree towards the boundary between the shallow region and the deep region. Okay, then third, what to do? We draw an arrow line BC. So this is arrow line BC. Okay, BC, which is closer to the normal. Okay, so why closer to the normal? Because deep to shallow region. Okay, so deep, shallow, towards. Duit saya tiada. Deep to shallow will be towards normal. Okay, so you can see the angle here is smaller. Angle of refraction here smaller compared to the angle of incident up there. So we understand it propagates closer to the normal. And then finally, you can draw 3 lines perpendicular to BC to represent the refracted wavefront. Why 3? Because above here we draw 3. If you draw here 5 lines, which means down here you must also draw 5 lines. That is the rule. Okay, if the incident wave have 3 lines, so down here the refracted wave also will show 3 lines. Okay, only different in distance because it shows either the wavelength is shorter or longer. So we draw the line closer, showing that the wavelength is shorter in the shallow region. And that's all. Finish. Itu saja. 4 langkah macam mana nak lukis perambatan gelombang air daripada kawasan dalam kepada kawasan cetek. So keyword dia daripada kawasan dalam kepada kawasan cetek, dia merambat menghampiri normal. Duit saya tiada. Deep, shallow, towards normal. Okay, so I hope you're clear with this. So, kalau nak lukis daripada cetek ke kawasan dalam pun sama juga. Use this for method for rules. Alright? Okay, next. Okay, let us practice this together. Mari kita cuba bersama-sama. You need to draw diagram of refraction of plane water wave using the 4-step guided in the previous slide. Okay, so this is our first situation. So the wave is travel from deep region to shallow region. Okay, so this is the wavefront of the wave in the deep region. So what is the first step? Yeah, you have to draw the incident direction of the incident wave. So we draw this arrow line, okay, together with the arrowhead. Second, yes, we draw the normal line. Very good. Okay, you draw the normal line. This is the normal line. Show. Okay. Third, yes, we draw the refracted line. Okay, the refracted line. So where? So this is deep to shallow. Remember, student, deep to shallow will be towards. So towards mean it will be closer to the normal line. So towards in this direction. Then final step, we draw the wavefront. So here. Okay. So here, if you can see 1, 2, 3, 4, 5, 6. So you can draw 6 lah. You can add more here. 6. Okay, 6 wavefront. So the line is closer, showing that in shallow region, the wavelength is shorter. Okay, so here I only draw 3, then you can add another 3. As here is 6, 1, 2, 3, 4, 5, 6, 7. Or how many you can see? So you can draw 6 or 7 line here. All right. Okay, then try the next one. Okay, now the water propagate from shallow region towards a deep region. Okay, shallow to deep. So we understand shallow to deep will be refracted away from normal. That is the concept. So first we draw the direction of the incident wave. All right. So direction of the incident wave. So this is the direction of our incident wave. And here, second step, we draw the normal. Okay, now this is the normal line. It must be 90 degree to the boundary. Okay, 90 degree to the boundary of the shallow and deep region. Okay, then, so from here, where to draw? You should draw away from normal. So this is our normal line. Away, so it will be upward direction, away. See, angle of refraction here greater than angle of incidence. Before that, angle of refraction smaller compared to the angle of incidence at this side. Right? Then we draw our refracted wave. Same situation. If you can see here, how many lines you can see here. So you have to draw the same number of line in the refracted ray. Okay, so that is the rules for drawing patterns of refraction of water wave. So here we use, saya dapat angpau, shallow, deep, refracted away. Okay, mean angle of refraction greater. Deep to shallow, refracted towards. Mean angle of refraction will be smaller. Okay, I hope you are clear with how to draw a refraction pattern of a plane water wave using DST, duit saya tiada, and saya dapat angpau tips. Alright, okay, next. Okay, so done with the second. Now let us try to explain a few examples of natural phenomena involving refraction of wave in our daily life. Can you give me one example, students? Example of daily life or what you can see every day around you which involve or related to refraction of wave. Either refraction of light wave, it can be refraction of sound wave, or it can be refraction of light wave as well. Alright? Okay. Ini Riza tadi, dia belajar di Perak. Okay, thank you for still being us, Rashid Riza. Alright, student. So talking about natural phenomena, okay, first this is the very common example, okay, in a water. Objek kelihatan lebih cetek bila dia berada dalam air. Okay, when you go into the pool, you appear to be shorter. Kalau anda masuk ke dalam kolam renang, perasan tak badan kita macam memendek, nampak lebih pendek daripada biasa. Actually, that is due to a phenomenon called refraction of light wave. As the light travel or propagate from two different medium, from air to the water, or the other way around, from the water into the air. Okay, so this is one example of a situation involving refraction of light wave. Okay, so you can see from the GIF here, this is where we put the coin, okay, at the bottom of the glass filled with water. So as we fill up the water to the full volume, okay, now the coin appear to the eyes of the observer, but it appear at the shallow depth. Okay, so this is how we draw the refracted ray coming from the coin at the base of the glass. So this is the image of the coin appear at the eyes of the observer. Alright, so it appear to be shallow. Then the image appear to be shallow than the actual object at the bottom. Same situation with the fish here. Alright, so due to refraction, this is actually the actual position of the fish, the yellow one. Okay, but due to refraction, the fish will be appear to be at the back, okay, from the original position. So when you are about to use a spear to catch a fish, you should aim lower at the back, okay, then where you actually see the fish is. Kalau anda nak gunakan tombak nak tangkap ikan, bila kita aim tu kita kena aim ke belakang sedikit daripada kena aim di hadapan sedikit. Okay, you have to aim your spear in front a bit from the fish you see in the water, because there is where the actual position of the fish. Kena aim di hadapan sedikit daripada ikan yang kita lihat. Kalau tak, nanti tak dapat. Okay, so you can try refraction of light. Alright. Okay, next student. I hope my internet connection is work well with me. Boleh tak anda respon kepada cikgu sama ada talian saya terputus-putus ke, suara cikgu terputus-putus ke? Okay, maybe we can have some response from you. Okay, student. Okay, this is another example. Why sound cannot be heard over a long distance on a hot day? Kenapa pada hari siang suara tu kedengaran tak jelas berbanding pada waktu malam? So how to explain this situation according to refraction of sound wave? First, what happened at the daylight? On a hot day, the air layer near the surface of the ground is warmer, hotter. Pada siang hari, lapisan air di permukaan bumi ni dia lebih panas. So what happened then? Sound wave travel faster in warm or hot air. Gelombang bunyi dia bergerak lebih laju dalam udara panas. Alright. Okay, then what happened next? Sound wave travel from hot air towards cold air above. Okay, so the speed of the sound decreases. So di bawah ni udara panas, di atas tu udara sejuk. So maksud dia gelombang bunyi ini merambat daripada kawasan udara panas ke udara sejuk. Okay, from the high density to a low density air. So the speed of the sound decreases. Okay, so by then the sound will be refracted away from the ground. So bila dia dibiaskan ke atas, sebab itulah kita dapat mendengar bunyi yang perlahan atau tidak jelas. Okay, so this is the explanation why sound cannot be heard over a longer distance on a hot day, because it is refracted away from the ground as it moves from hot air to the cold air above. Alright. Okay, then what happened at night? Pada malam hari pula, kita dapat dengar suara bunyi dengan lebih jelas, dengan lebih kuat. So what happened at night, students? So at night, the ground cools, which means the air layer near the ground is cooler. So pada malam hari, lapisan udara di permukaan bumi itu dia lebih sejuk. Okay, mean yang udara di atas tu dia lebih panas. So what happened here? Sound wave travels slower in cold air. Cold air is a high density air. So sound travel slower at the high density medium. Okay, then sound wave travel from cold air, which is from the ground, to hot air, which is above. So what happened to the speed? The speed increases. So by this, it is refracted towards the ground, right? So sound wave refracted towards the ground. So by that, we can hear the sound clearly at night compared to in a day. Alright, berbanding pada waktu siang hari. Okay. Third, okay, so this is the third daily situation involving the refraction of water wave. Why the wave become closer to each other and follow the shape of the shoreline when they are approaching the beach. Anda lihat, kalau kita berdiri di tepi pantai, bila ombak itu datang, dia akan mengikut bentuk pantai. Okay, so this is again due to refraction of water wave. So student, here you can see away from the shoreline mean the water at the deep ocean. Okay, pada laut dalam tu, if you see here, the wavefront of the water is almost straight and parallel. Why? Because at this region, water wave is moved at uniform speed. Di kawasan tengah laut ni, kalau anda lihat, ombak dia sekata kerana halaju ombak itu adalah seragam. Okay, the wave move at uniform speed. And as they're approaching the beach, semakin dia menghampiri pantai, apa berlaku? So this is what happened. So here you can see two parts of the shoreline. The first part we call as the cape. Bahagian ni yang menganjur keluar tu kita panggil dia tanjung. Okay. And then this one that curving inwards, we call it as a bay. Bahagian yang menganjur ke dalam ni kita panggil dia sebagai teluk. Alright. So what happened at the cape? You can see here at the cape, it is shallow water region. Okay. At the cape is a shallow water region, while the bay is a deep water region. Alright. So what happened at the cape when the wavefront of the water propagate to the cape? Okay, so the speed of the water wave decreases, okay, causing the wavelength to be shorter. So the wavelength is shorter here. Okay, and then what happened? The wavefront of the water approaching the bay. Okay, meanwhile at this region, what happened? It moved at the higher speed because at the deeper depth. Then the wavelength is longer. Remember, when the depth is deeper, wavelength is longer and speed also higher. So this causes the wavefront to form a curve shape, and then follow the shape of the shoreline. So here it follow the shape of the cape, and here it follow the shape of the bay. All right. Okay, so you can read back again for further understanding later on. Okay, now here number 4. Why the water at the cape has high wave? Kenapa ombak di kawasan Tanjung ni dia lebih deras berbanding dengan ombak di kawasan Teluk ni yang lebih tenang. Okay, the wave at the cape is high wave and it is calmer at the bay. That's why when we go to a beach, we are recommended to take a bath here. Kita digalakkan mandi di kawasan ini, mandi di kawasan Teluk, and you are not recommended to do your activity here at the cape sebab dia agak bahaya kerana ombak dia agak deras. So why there is a difference in these two situations? So what happens, student, if you look at the shape, okay, the cape has a convex shape. The cape has a convex shape. So the wave there will be converged to a point. Mean the energy there will be accumulated. So more energy is converged at the cape due to the converged shape. And at the bay, you can see it is a concave shape. The bay has a concave shape. So what happened when the wave propagate there, it will be diverged. Okay, we will learn later convergent and diverging lenses when we study chapter 6. All right. So again at the bay here, so the wave energy will be diverged. So as the energy diverge, so the energy there will be lower compared to the energy at the cape. So here water has a high amplitude, so high energy. So a bit dangerous for water activity. So it is more safe if you do your activity at the bay. All right. Okay. Next. Why the water at the bay is calmer? So this is the same reason I show you just now. Okay, the energy is spread to a wider area because of the converged shape. Okay, so the wave there will be diverged to a wider area. So this will reduce the amplitude or reduce the energy of the wave there. So it is more safe to be swim or to build a jetty at the bay. Alright. Kalau dia tanya kat mana tempat yang lebih sesuai nak mandi, di Tanjung ke atau di kawasan Teluk? So the answer is di kawasan Teluk itu lebih sesuai untuk mandi kerana ombak dia lebih tenang kerana tenaganya telah disebarkan ke kawasan yang lebih luas. It is more safer to swim or to build a jetty at the bay because the wave has been spread or diverged to a wider area, so causes the amplitude or the energy of the wave to be reduced. Okay, boleh dengar boleh faham setakat ini, students? Okay. Now again, this is to show you the changes of wavelength when water propagate into a different depth or different depth or different region. Okay, here, can you tell me which one is the shallow region, which one is the deep region? So here you can see the wavelength is longer. So we understand this is on the left side is the deep region. And here you can notice the wavelength becomes shorter. So this is the shallow region. So deep to shallow, refracted towards normal. All right. And then this one, same situation also. Okay, you can see on the depth, on the deep region here, see the wavelength is longer. Okay, the wavelength is longer. Meanwhile, at the shallow region, you can see the wavelength is shorter. Same goes to the speed. All right, wavelength longer here. Actually, the arrow should be pointed to this direction. Okay, wavelength longer, wave speed higher, and when the wavelength is shorter, so the wave speed also will be lower. Okay, so I think let us take a short break for a while. We will come back after this with more example of situation involving wave. Okay, so don't go away. See you after this short break. So you are now back with me, Cikgu Hasnitah. I'm currently teaching in SMK Bagan Jaya, Butterworth, Pulau Pinang. So this is physics online classes for Form 4, Chapter 5, 5.4, Refraction of Wave. Okay, so now let us continue with the next learning standard, which is 5.4.4. This is to solve problem involving refraction of wave. Okay, students, again, you can download and print out the PDF copy for this class. And the link show here in the screen, it is pinned in the live chat. So you can download and print them out for free. Semuanya anda boleh muat turun, cetak keluar secara percuma saja. Cikgu harap membantu anda untuk mengikuti kelas ini dengan lebih baik. Alright, okay, next. Okay, so what kind of problem we are having this afternoon? Okay, before that, we have Mr. Pear there. Thank you very much for joining us, Mr. Pear. Thank you very much for your support. Okay, selamat belajar semua, Mr. Pear kata. Okay, anda akan bersama dengan Mr. Pear minggu hadapan untuk tajuk yang seterusnya, iaitu diffraction of wave 5.5, pembelauan gelombang. Okay. Okay, anak-anak, so kita teruskan. Okay, before that, this is the formula from the speed of wave. V equal to F lambda. V is the speed of wave, where F is the frequency of the wave and lambda refers to the wavelength. So we can apply this formula for refraction of water wave in a deep region and shallow region. So, how to relate this formula in order to solve a problem involving propagation of waves. So this is what it will become. V1 divide lambda 1. Actually, this is the frequency of the wave in the deep region. Which is equal to the frequency of the wave in the second region, is the shallow region. V2 divide lambda 2. So if given any of these quantities, so we can find V1, you can find either lambda 1 or you can find V2 or lambda 2. Okay, so the formula again, V1 divide lambda 1 equal V2 divide lambda 2. Alright, okay, now let us apply the formula in this objective question. Okay, so let's work together with me. Which one is your answer? 1, 2, 3, 4 here consider as A, B, C, D. All right. Okay, first, so we have diagram show refraction of water wave. So it propagate from deep to shallow region. This is the wavelength on the deep region given there 3 cm, and the wavelength in the shallow region is given 1.5 cm. Okay. If the speed of the water wave is 5 centimeter per second in the deep region, so you can highlight this information. So find the speed of water wave in the shallow water region. So first and foremost, you must understand what is the given information here. Okay, the first step. So you are given with lambda 1, lambda 2, and we are given with V1, which is 5. So now we are finding V2. V2 is the speed of the wave at the shallow region. Yes. Okay, so we put the value in. We do the substitution. This is the formula. We apply Okay, so this is 5 centimeter, the speed of wave at the deep region, and this is its wavelength, 3 centimeter. You don't have to convert it to meter, no problem. All right, and V2, this is what we are looking for, the speed of the wave in the shallow water region, where the wavelength there is 1.5. Okay, students, so what is V2? If you have found the answer, is it 1.5, 2.5, 3.0, or 5.0 centimeter? Again, 1, 2, 3, 4 represent A, B, C, and D. All right, okay. So we get here 2.5 centimeter per second. Okay, V2 is 5 multiply 1.5 divide with 3.0. So answer 2.5 centimeter per second, which is B, boy. Yeah, the second answer. Okay, so this is basic understanding on how to determine either wavelength or speed of wave in deep or shallow water region. Okay, next. Okay, the second question, again, objective question here. Okay, diagram 3 show a ripple tank with a sloping base and a vibrator being vibrated. So this is the sloping base to create a different depth region. Okay, so here you can see under the vibrator is a shallow region. And at the end of the ripple tank, you can see this is the deep water region. All right. Okay, so which of the following wave pattern you will observe on the screen? Student, this is SPM 2006 question. Okay, which one do you think? So here we understand shallow water region. So what happened to the wavelength? Longer or shorter? Very good, it is shorter. And here at the deep water region, the wavelength is longer. So which one should be the answer? Mana jawapan dia? Yes, it should be A. All right. Shorter at the shallow region and longer at the deep water region. Okay, next, number 5. Similar, the question is about similar, but now this is the pattern of the wave show. Which pattern of the wave fronts will be observed in the basin? So you just have to check which one is the shallow region, which one is the deep region. So on the right is shallow, so the wavelength here should be shorter. On the left side is deeper, mean the wavelength should be longer. So answer for this should be A. Longer here, show deep region. Shorter at the right, showing shallow region. All right, very good. Okay, next. Okay, again, you are given the situation involving water wave. The wave travel from region P, this is region P on the left side, to region Q on the right side at different depth. Okay, so from the wavefront, students, can you guess which one is the shallow region? Which one is the deeper region? Yes, very good. So P is a deep region. Okay, Q is a shallow region because the wavelength is shorter. Here the wavelength is longer. Okay, very good. So speed of the wave is 18 centimeter per second in region P. So this is the speed at the deep region, 18 centimeter per second. So you have to find the speed in the shallow region of Q. Before that, you are given this length, 12 centimeter from this end to the other end. Here also 12 centimeter from this end of Q to the other end of Q. So actually from this distance, we can find the wavelength for each region. How to find the wavelength at P? How to find the wavelength at Q? So you should have divide 12 with the number of lambda we have here. So how many lambda you can see here in region P? So how many lambda you can see there? So you can check. This is the first lambda. Okay, so this is our first lambda. So lambda 1. Okay, I mean this is lambda 2. This is lambda 3. And this is lambda 4. So there are 4 lambdas. They mean 12 should be divided by 4 to find the lambda. Okay. So this is the calculation. Okay, wavelength in the first region, as I show you there, 12 divided by 4. Then here 12 divided by 4. So it is 3 centimeter. Okay, and in region Q, how many lambda we have there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 lambda. So 12 divided by 8 means the wavelength is 1.5 centimeter. Okay, so now we have lambda in P and lambda in Q. We have speed in P. So now we can find the speed in region Q again by applying this equation. So simple. Okay, so you just do the substitution. 18, this is the speed of wave in P, the wavelength at P. So this is V2, the speed at Q. 1.5 is the wavelength at Q. Okay, so you rearrange. So V2 will be 9 centimeter per second squared. So here we understand when the wave travel or propagate from deep region to shallow region, what happened to the speed? The speed decreases from 18 centimeter per second decrease to 9 centimeter per second. So do the wavelength decreases from 3 centimeter decrease to 1.5 centimeter. So which quantity remain the same? Very good. It is the frequency. Yes, because they are coming from the same sources of wave. Very good. Okay, next. Okay, students. So now we have the next question. Again, okay, we have diagram show plane water wave with the frequency. So this is the frequency given propagating from deep region. So from deep region to shallow region of PQ. Okay, so the wave is coming from this, from the right to the left, from deep region. This is the arrow shows here the direction of the incident wave. So this is the normal line. Okay, the green dashed line is the normal between the two boundaries of the deep and shallow region. So first, calculate the wavelength. Okay, calculate the wavelength. So how to find the wavelength? This is the formula you are given. So you are given with the frequency. So we have the speed, so we can find the wavelength by using this formula V equal F lambda. Okay, so we do the substitution. So the wavelength will be 3 centimeter. All right, for 3 centimeter. Lambda is 3 centimeter. Okay, now find the speed of the water in the shallow region if the wavelength is 1.5 cm. Okay, so again, we apply this formula. Okay, now either than using V1 divide lambda 1 equal to V2 divide lambda 2, you can also apply this because why? The frequency is the same, okay, in the deep and the shallow region. So here we can also apply this formula V equal F lambda. So frequency is 10, similar to the frequency in the deep region. So this is the wavelength of the shallow region. So we can find the speed here is 15 centimeter per second. Again, you don't have to convert into meter. Just leave it in centimeter per second. No problem. All right. Okay, next student. Okay, now using arrow, you have to draw. This is from the same question. Now part C. Using arrow, draw the direction of propagation of the wave in the shallow region and sketch the wavefront of the wave refracted in this region. Okay, so first you must understand the wave is travel from deep to shallow region. So we use DST, duit saya tiada. So duit saya tiada, deep, shallow will be refracted towards normal. Okay, so this is our incident wave. So this is the normal. So it should be refracted towards the normal. So you can see here, angle of incidence greater than the angle of refraction. Okay, angle of incidence greater than angle of refraction. Okay, so How many wavefront? You can see here 1, 2, 3, 4, 5, 6. Here I draw 3, so you have to add another 3. Okay, with the same distance. Lukis lagi 3, tapi bagi jarak dia sama lah. I don't have a ruler here, so my drawing is quite poor. So 1, 2, 3, 4, 5, 6. Showing that the wavelength decreases, so we should draw it in a shorter distance. Okay, so I hope you're clear how to draw the pattern of the water wave traveling from deep to shallow region. Using this formula, deep, shallow, propagate towards. Okay, then compare frequency, compare the wavelength, and compare the speed in the deep and shallow region. So what happened to the frequency? Frequency is equal. In the deep and in the shallow region, the frequency is the same. Okay, wavelength, the wavelength in deep region is greater or longer compared to the wavelength in the shallow region. And wave speed, yes, the wave speed in the deep region also greater or higher than the wave speed in the shallow region. All right. So I hope you're clear how to do this question. Okay, now student, let us try to do some example of structure question. Okay, number 3. You are given a diagram 3.1. It shows a spoon in a cup of water. Okay, you can see that the spoon appear to be bent inside the cup of water. So first, name the light phenomenon involved in this diagram. So what is the light phenomenon involved here? So name the phenomenon. It is, yes, refraction. Refraction of light wave. Pembiasan gelombang cahaya, or you just say pembiasan enough. You just say refraction will be enough. Alright, okay, then explain how the light phenomenon in this diagram happen. Okay, how does refraction of light occur? So where to begin? Yes, you can begin with the propagation, the changes in medium. So light propagate from low optical density medium to a high optical density medium, means travel from A into water, or you can mention light propagate from air into water. So light propagate from low optical density medium, which is the air, to a high optical density medium, which is the water. So second, what happened? Yes, the speed of light decreases. Okay, in water, the speed of light decreases and refracted towards normal. Okay, the speed of light decreases and it is refracted towards normal. So as the consequences or as the result, the spoon will appear to be bent inside the water. All right, next. Okay, now students, this is past year SPM question, but I don't remember exactly which year it is. So diagram show a boy beating a drum, produces sound which can be heard by a man. All right. So first, what type of wave is sound wave? Do you remember what type of wave is sound wave? So sound wave is transverse or longitudinal. Remember? Very good. Sound wave is, yes, longitudinal wave. Gelombang membujur. Okay, next. Okay. Explain how the sound produced by the drum and can be heard by the human. Macam mana suara itu dihasilkan oleh gendang dan akhirnya dapat didengari oleh telinga manusia. So what happened when the drum is vibrate, or when the drum is heated, so it vibrate. So the air particle vibrate parallel to the direction of propagation of the wave because it is longitudinal, right? So when the drum vibrate, a particle vibrate parallel to the direction of propagation of the wave. Okay, and then what happened? It will create a compression and rarefaction region. Remember, when we talk about longitudinal wave, when the wave propagate, it will create compression, rarefaction, compression, rarefaction region. Okay, alternately. Okay, and then energy will be transferred from where? From the drum to the human ears. Okay, the energy propagate in the same direction of the propagation of the wave, which is from the drum to human ears. And finally, our eardrum vibrates and heard the sound produced. Of course, our brain will tell us what kind of sound you are heard. So the eardrum vibrates and heard the sound produced. Okay, so this is to explain how we can hear the sound coming from the beating drum. Right? Okay, next. Okay, this is the next question. You are given diagram 3.2. It shows sound wave produced by a boy singing at the distance to his camp. So the boy is singing at night. Okay, appear that the colleague here able to hear the sound from the boy. Okay, so what happened? The first one, what is the meaning of longitudinal wave, student? Just now they ask you what type of wave. Now they ask you for definition of longitudinal wave. So, yes, longitudinal wave is where the particles of the medium vibrate in the direction parallel to the direction of propagation of the wave. That is longitudinal wave. Okay, zara medium bergetar pada arah yang selari dengan arah perambatan gelombang. Okay, and then give one reason why sound can be heard louder at night. Kenapa bunyi boleh didengari lebih kuat pada waktu malam? So as we discussed before, so first sound wave refracted towards it. Okay, for this one it allocate 2 marks. 2 markah saja. So jawapan kita pun agak pendek. So sound wave is refracted towards the ground. Yang ini dia 1 markah saja. Sorry, dia tanya kenapa? Satu sebab, 1 markah. So we just say sound wave refracted towards the ground. Kalau dia 3 markah atau 4 markah, then kita kena cerita sedikit. Okay, what happened at night? The air near the ground is cold. Okay. So sound travel faster or slower at cold air. So we mentioned as the previous slide. Okay, then finally sound wave is refracted towards the, but for this one, since it only allocate 1 mark, 1 reason, so it is because sound wave refracted towards the ground. All right. Okay, next student. Okay, this is the long essay. I think our last question for today. Essay which carries 10 marks. Okay, the designation of a structure of a retaining wall in order to select the best new harbor to be built. Okay, so you are given a few characteristics. First is the location, either at the bay or at the cape. And then the surface of the retaining wall, we have 2 choices there, either uneven or smooth surface. And then the height of the retaining wall, either high or low. And the structure here with sloping or a vertical retaining wall. So there are 4 characteristics or 4 aspects. So here we can use the tick to pick method. Okay, so before you choose, you can tick your characteristic you are prefer with. So number 1, from the location. So remember, just now we mentioned which one is the most recommended place to build the jetty or the retaining wall, at the bay or at the cape, where the wave is calmer. So we choose bay. So mean we choose location at the bay. So we tick the characteristic. And then the structure of the retaining wall. If you look at the structure, vertical or sloping or vertical. Sloping mean it is thicker at the base. Vertical, it is uniform from the top to the base, just uniform. So in order to withstand high pressure at the bottom due to water, so it is a better choice if we use the base which is thicker at the base. So we choose sloping retaining wall. So this is sloping retaining wall. Okay, and then talking about the surface of the retaining wall, better to be even or better to be uneven or better to be smooth. Okay, students, so for this one, uneven surface is a better choice. So later we will see the reason. Okay, and finally the height of the retaining wall, of course we will choose a high retaining wall. Okay, from the logic way, so we choose a high retaining wall. So now you can see which type, okay, have the most number of ticks. Okay, so W we have 4 ticks, X we have 1 tick there, Y 1 tick, Z we have 2 ticks. So according to the selection here, W is the best choice. So then what do we need to do? We construct our table of answer. Characteristic and the reason on the right. So first, the location we choose at the bay. This is the reason because the wave there is calmer, okay, or the wave there has a low energy or low amplitude of wave, okay. Then so it means it will be safe from being crushed by a big wave. Okay. Then the structure of the retaining wall, we choose a sloping one, bercerun. Kenapa? This is to withstand high pressure of the water. Okay. Then the surface of the retaining wall, we choose uneven surface. Why? So that the wave will be reflected when the wave hit the surface. So it will be reflected in many direction. So it won't reflected at one point only. So it will be reduced the energy of the wave coming. Alright. Okay. Then the height of the retaining wall, it should be high. Kenapa tembok tinggi lebih sesuai? Supaya dia dapat menghalang gelombang tinggi, prevent high wave from destroying the wall. Okay, or you can say water not spill, not allow water to flow. And finally, our selection. So we choose W. Why? So we write back all the characteristic for W because it is located at the bay, sloping retaining wall, uneven surface, and high retaining wall. Okay, so this is the format of answering the 10 essay question. You are recommended to answer in a form of table, so easy for the marker to see your point and easy for you to help you to get marks. Alright. So student, I hope that's all for today. Itu saja masa yang kita ada. Alhamdulillah, walaupun mungkin ada beberapa tempat yang agak terputus talian, so cikgu minta maaf atas segala kekurangan, but Alhamdulillah we have are able to finish our class today. So I would like to thank you very much for your great effort and hope to see you again in our next lesson. So jangan lupa, terima kasih kerana bersama-sama dengan kami pada petang ini. Anda boleh tonton semula video ini pada link yang sama dan boleh pause pada mana-mana bahagian untuk anda lebih faham sambil-sambil anda boleh lengkapkan latihan yang cikgu berikan. Jangan lupa boleh muat turun, boleh cetak keluar latihan ini secara percuma saja. Semoga usaha kecil ini dapat membantu anda untuk faham tajuk ini dengan lebih baik. So jangan lupa bersama-sama kami lagi pada minggu hadapan, hari yang sama, iaitu untuk kelas tingkatan 4. Kita ada Cikgu Teachers Lin dan Nordin minggu hadapan akan bersama-sama kita untuk tajuk seterusnya 6.2. Okay, tenaga nuklear. Dan untuk kelas tingkatan 4 akan disambung oleh Mr. P. Tajuk dia 5.5 Diffraction of Wave. That is for DLP classes. Same time, same day, Sunday 3:30 PM. Jangan lupa, saya ulang sekali lagi, kelas tingkatan 5 Jumaat 9.30 malam bersama dengan Teachers Linda Nordin dengan tajuknya 6.2 reputan radioaktif dan juga 5.5 Diffraction of Wave Mr. P Ahad 3.30 petang. Jadi insya-Allah mudah-mudahan apa yang kami bawakan pada setiap minggu membantu anda untuk memahami fizik itu dengan lebih baik. Jadi segala yang baik itu daripada Allah, segala yang kurang itu daripada kelemahan dan kedangkalan diri cikgu. Sekali lagi cikgu ucapkan terima kasih kerana bersama-sama dengan kami. Semoga sesi kita petang ini memberi manfaat kepada semua yang menonton. InsyaAllah kalau ada sumur di ladang boleh kita menumpang mandi. Jika ada umur yang panjang, InsyaAllah kita berjumpa lagi. Sekian dulu. InsyaAllah berjumpa lagi dalam siri yang akan datang. Assalamualaikum warahmatullahi wabarakatuh. Bye-bye semua.